All right, let's get started. Well, hello everyone. My name is Luis Figueroa, and I'm one of your chapter leaders. I wanted to welcome you to our second March meeting. We're very excited about the speaker lineup we're putting together this year, and we're really looking forward to our upcoming sessions. For those new to our virtual chapter, our meetings are focused on all aspects of the data science lifecycle, from data acquisition and transformation to statistical analysis and data representation. So we cover both academic and technology-specific topics. So we have a great presentation for you today, but before we dive into the presentation, I'd like to take care of some housekeeping items. So if you haven't heard, so there is a great business analytics conference organized by PAS coming up on May 2nd in San Jose, California. So to learn more about this conference, visit its website at http://PASS, that's PASS, conference.com. So take a look, and if you're interested in registering, we can provide a discount code to our members or to the members of this virtual chapter. To obtain your code, just email us at datascience@sqlpass.org. Also, if you like free training delivered to the comfort of your office or your home, don't forget to check out the other past virtual chapters. There are many chapters covering a wide variety of data-related topics. So regardless of what your data specialty is, you'll find something interesting for you. So check them out. So PASS, in collaboration with the local chapters, also organizes a very popular conference called SQL Saturdays. In the current slide, you can see a list of some recent and upcoming SQL Saturday events. For a full list of events, go to www.sqlsaturday.com. Also, PASS would not exist without its global network of passionate, dedicated, and hardworking volunteers. So if you want to get involved and you want to check out the volunteering opportunities, visit the volunteer website at volunteer.sqlpass.org. And lastly, I'd like to extend an invitation to you to stay involved. So you can follow us through any of the social media services shown in this slide. But also, if you are a data science practitioner and would like to share your experience on any related topics, please contact us at datascience@sqlpass.org. We would love to have you speak at one of our meetings. So now we have a great presentation for you today. The title of the presentation is Being Smarter with Azure Machine Learning and R. Our speaker is Leila Etaati. Leila is a data mining and BI consultant at RADACAD, an international speaker for several conferences such as SQL Rally, New Zealand Ignite, SQL Saturday, Codecamp, and others. She is also a lecturer and trainer at the University of Auckland. She holds a PhD of Information Systems from the University of Auckland. Before I make Leila a presenter, I just would like to ask you if you have any comments or feedback throughout the presentation, please enter those comments on the chat window. If you have any questions that you'd like to have answered at the end, use the questions window. So during the presentation, we'll be monitoring both, but we'll answer the questions posted to the questions window at the end. I see there were some questions about the slides. Are you guys currently seeing the slides? Let's see. Can you guys see? No, huh? All right. Okay. Well, we are going to, I'll include the slides on the email that we'll send out after this presentation. So there's also going to be a recording available on the YouTube channel. Apologies for that. It definitely shows as showing the presenter slides here on the webinar panel. I'm not sure what happened, but so let's switch to Leila and let's make sure that you can see her slide before we move forward. So let's go ahead and make her a presenter. All right, Leila. Whenever you're ready, you can share your screen. I see. Looks like I had a glitch here with my show screen option.
I couldn't see the option for share my screen. Can you?
It should be on screen sharing on the top of the Go to Webinar control panel.
No, just now it's just share my webcam. There is no one. Have you made me my presenter?
Yes, let me try that again.
Oh yeah.
Okay.
It's come up.
Yeah, there you go.
Okay. So hello everyone. I'm Leila. I'm going to talk about the Azure Machine Learning and R. And how they can helpful for our decisions making and the other stuff. I'm talking from New Zealand. I come from future. Today is 25 of the February, March. So it's actually, I'm also going to talk about the future. So let's talk about my background a bit. For today, I'm going to talk about the first, what is machine learning, and I will talk about that, how is the process, what's the story of machine learning, and then I will talk about Azure ML. I will show you a couple of demos on Azure ML and R with Azure ML, and then some facts and figure about the Azure Machine Learning. I hope that you enjoy the session. So, first of all, what is machine learning and what is data mining? The goal of machine learning is to build a computer system that can adapt and learn from their experience. So they should learn from the data that we have previously. They can learn from what happened in the past, and based on that, they can predict the future and make decisions based on that. The very simple example of using machine learning and data mining is on distinguishing the mail from the spam and inbox. So here is the engine that learn from the previous data, previous email, and based on that, this can distinguish that this is a spam email or it should go to inbox. So based on the subject of the email, based on the type of the email, and also the center, it's learning, and it can predict in future which email should go to which folder. Another good example happened in the United States Postal Service. In 2013, about 150 billion pieces of email were processing and very accurately sent to the people. But in 1997, there was not like that. There's a lots of problem in reading the handwriting email. So the subject of the email was a bit but not readable for most of the post office. So the challenge in automation is enabling the computer to interact endless variation in handwriting. As you can see here, people may write refer in a different way. So as you see, so the aim of the machine learning is to read and to see these variation and can distinguish them. And based on that, so there's a lots of these machines should get lots of feedback from the people who read these mail, and also seeing different shape of the writing, the refer, to able to predict the future, that how people write the refer word. Another good example of machine learning is Kinect and Xbox, Microsoft Kinect and Xbox, that they able to see and to predict what movement people do in front of the Kinect and Xbox. So they, based on the people shape, people age and the size of the people, style of the people, they can identify that these people are going to, for example, move right or left or going back and forward. So they can distinguish, they can predict based on the previous data that they have. So from data to decision, how data help us? The previous technologies, the previous from 2014 until before, we use data just to tell a story about what happened, and we try to see that what happened, and based on that we can have an insight about the data. The next one that we come approach is about the interactive dashboard. So why did it happen? So we are going now to analyze that, why this phenomenon happened and what's the main cause of that. Now we come up, these days we come up with a prediction that what will be happen. So we are going to actually look at the what will be happen based on the what happened in the previous. We are going to predict what happened in the future. So now we have actually, we are going to telling a story about based on the what happened in the past to predict the future. And definitely the next step is recommendation, that based on the what happened, now we are going to provide a recommend to do some specific, for example, recommendation on buying the specific product or selling specific one. So here is actually the trend that we have. We start from the past and now we are going to future. So we talk about the past and now we are going to talk about the future. So the first question that's come up is that, should I use machine learning or not? If the number of the data is small, no, there is no recommendation to use machine learning. And also, there should be a lots of data about the past, lots of history we need. Otherwise, it's not able, the machine couldn't learn from the previous data. And also, there shouldn't be any rule on the data. So we are going to look at the natural trend in the data. There are many variable tools for machine learning. As you see here, machine learning platforms like R, RADACAD, and Python have been used for many years. Also, we have many data mining tools like Orange, RADACAD, and also Microsoft data mining tools that comes with SSAS1 SQL Server. And besides that, we have some remote machine learning tools. The Amazon one, the Google one, and also the Azure Machine Learning for Microsoft. So there are a variety of the product here. It's common that all of these machine learning use these concepts and use these process. So the first concepts that all of these machine learning are important for them is about the data. As I said, that the previous data about the phenomenon is really important. So there should be lots of data about what happened in the past. And also, we need a model. We need a model to help us to predict the future. A good model, a right model we should choose. And the third aspect, concept that we need is parameters. Parameters, for example, if we want to buy a car and if you want to sell a car, we see a lots of factors that will affect on that. For example, the people age, the people actually number of children that they have, the salary that they have. All of these factors, all of these parameters will affect on buying a car. So based on these three concepts, machine learning can learn from the past, and based on that can predict the future. So the first step in all machine learning process is to define a business rule. For example, find a fraud, sales more, find potential customers. The second step is to find the right data and clean the data. So maybe we have to extract and transfer. For example, removing the missing data, or we just did some specific. For example, passenger ID or the student ID may not affect on the finding who can be the first class in our in the university. So we should find the right data and clean the data. The third step is finding the best model, choosing the model that's appropriate for our aim. And after that, now we have the model, we have data. Now we should train our model. We should help our model to see and learn from the past data. So we have to split the data, some percentage for training and some percentage for testing. So we first train our model, and then that we train, we are going to see that how it works based on the past data, how it can be good and how it can be trustable. Azure Machine Learning is actually part of the Cortana Analytics suite. So you can see here that we have machine learning. But as I said that we need data. So information management using Azure Data Factory, Azure Data Catalog, and the other help us to gather the data and actually form the data and clean the data. The next step is to store them in Azure Data Lake or Azure SQL Data Warehouse. And the next step is about getting the insights from the data. So using the machine learning and analytics, like using Azure Insight or Azure Stream Analytics, and also machine learning. And after that, we can provide lots of report and presentation based on our results. So using the dashboard and visualization help us to provide a better insight for our end user. If you look at the Microsoft machine learning process, you see that it starts from 1999. That's computer works on user behalf, filtering junk email and the rest. It comes to the 2004, that's the Microsoft search engine built with machine learning, and then SQL Server enabled data mining. So this is the first step that the user are able to actually use the algorithm, use the CAN algorithm in SQL Server. And it comes to the 2014 that Microsoft launches Azure Machine Learning. Okay, I'm going to show you a video and how AccuWeather use the Cortana Insight and also Azure Machine Learning to examine the traffic pattern and other user information. So just look at the video.
Our mission statement starts out with protecting lives, protecting property, enhancing people's lives. We do here at AccuWeather. HD Insight is a product on the Microsoft Cloud that allows us to do really high resolution, big data analytics with very little effort from us to bring out the infrastructure. Analyzing where our users are coming from, where our traffic patterns are, who our primary users are. That's just great to be able to do that. As the world changes, it's more and more computer driven. More and more machine learning is important to produce those forecasts. They're able to help us move our business forward with their technologies.
Okay, so as a data scientist, also you see that how AccuWeather can be helpful, how AccuWeather use the machine learning and also Cortana Analytics to actually predict the traffic and the rest. So as a data scientist, it's not just about algorithm. To be a good data scientist and use that knowledge, we do not just need the algorithm. It's not just about the model. We also should be cope with the data. We should clean the data and access to the right data and appropriate data. And after that, we create the model. There is a need that also we have a knowledge about about how to program, how to bring it to the end user. So to be a good data scientist and also actually to have a great knowledge about that, is always good to have a knowledge of all these three skills. Microsoft Azure Machine Learning is an end-to-end product that provides all of these things together. So it provides a place that people can load data from different locations, and also it provides a data transformation component for cleaning the data. It brings various about 25 algorithms that are already used in other Microsoft products, and they are actually available for the user to use. And also there's a lot of connection with R and Python language, so the people who knows with these language can use the package. Azure Machine Learning. And finally, there's a web service that the user can actually create that web service and can create a one for the end user. So you can use machine learning to do recommendation, to fraud detection, anomaly forecasting, image detection, and classification. So it can be used in different areas. Before I starting about the demo, I just first want to talk about the sort of what sort of problems we can solve. We have three types of the algorithm in Azure Machine Learning: classification, clustering, and regression. And each of them are responsible to solve a specific problem. Clustering algorithms are more responsible to do the descriptive analysis. For example, which other customer have similar preference to this one? What are the most common pattern in gasoline price changes? Clustering algorithms, these models actually helps people to find a trend, to find the behavior of the data. And you're not going to predict anything. They just help us to find the natural trend. Regression algorithm and classification both are predictive. So they help us to predict based on the previous data, we can predict the future. But there's a slightly difference. Regression algorithm able to respond to the question like, when will this customer make another purchase, or how many new followers will I get next week? So these two questions answers can be from, it's a continuous variable. So for example, for the followers, I can have 1 to million followers. And also for the classification algorithm is a bit different. For example, will this customer click a link or not? So it's a yes and no question. Or which offer should this customer receive? Is also a kind of the classification. So they predict the classes yes or no. For example, which offer. If we have, for example, 5 options, it predict that which offer should be provided for our end user. So as you see, we can in different area, we can answer different questions. For example, which vehicle needs serving most urgently? So it's we have, for example, 10 type of the vehicles, and to solve the question, we should use an algorithm and a model on multi-class classifications. So there are 3 main types. That's regression, classification, clustering, and classification. However, there are many algorithms there. There is a cheat sheet on Microsoft Azure Machine Learning that helps you to go through that. For example, here, if the data in rank order categories, if it's yes, you should use the ordinal regression. So there is a guide that you can use for algorithm. So let's look at the machine learning demos. Any questions so far? Okay, so I'm going to show you the Microsoft machine learning demos. So here. So this is Microsoft machine learning. So if you want to go, you should go to studio.azureml.net. So it's a place that you can create your first machine learning experiment. So to do that, we should go to experiment and create a blank experiment there. So here is also you can log in as a actually use your Microsoft account or as a guest. So both options are available. As you see that the experiment is actually drag and drop environment. So you can just drag the component from here and put it here. So I'm going to have a demo on Titanic classification algorithm. It's about the data set that about the people who already survived in Titanic disaster. I'm going to provide a yes and no problem. It's a yes and no problem. We have to see that if people with a specific age, gender, and passenger class, are they going to survive or not? So here I'm already import the data about the Titanic. So I'm just the Titanic. Oh, sorry. So I'm going to look at, I'm going to import the data about the Titanic. I think that I'm in a free one, so I'm going to actually log in and to my account. Sorry about that, there's a problem here. So I'm going to sign in as my live account to see the previous data that I'm already entered into the Azure portal. So here, not now, I'm going to create a blank experiment. So here is actually a database that exists. There are some sample database and there are some that you already entered there. So I'm already provided database about the Titanic one. So by clicking on the node, you can see the data visualization there. So you see that it has about 12 columns and 891 rows. So you see that we have passenger ID, we have information about the people survived, and you see the diagram here that shows the distribution of the data. Also here you can see some statistics. So for example, for the passenger class, you see that we have the medium, and also we have the standard deviation, missing value, and also the actual chart. To start, I should clean the data. So the first step is to, I have a data, now I'm going to clean the data. I know that the gender, age, and passenger class will affect on survival of the people. But for example, passenger ID, name of the people, and for example, ticket number are not affect on survival. So I'm going first to remove some of the columns that I think they do not have any impact on the data. So I'm going to use the transformation module, that's a project column here, to remove the data that is not necessary for me. So I'm just launch the column selector, and I'm said that I want to exclude the passenger ID, name of the people, ticket, fare, cabin, and embark. So, and I put a name, Titanic data science. Okay, so I'm just run the code, run the model to see that how is actually apply the changes. After that I remove the columns, I should search for the missing value. So just look at the result and see that here. So there should be just 4 columns here, as you see. Now, the next step is about the removing the missing value. Look at the age column. You see that about 177 of rows are missing. So I should do something for that. So I'm using another transformation module, but that the name is cleaning missing data to do that. So I'm just connect them, and here I'm said that I'm going to apply it just to the age of the people, and I have a different option. For example, I can set that you can replace it with a mean, medium, mode, and the rest. So I'm set that replace it with a mode, and also here you can set that remove or progress that. So if I just run it, you can, after that you should see that it's remove the missing data. So I remove the parameters that I think they are not relevant, and then also I'm clean the data, remove the missing value, and actually replace them with a specific data. So if you just look at here, you see that the missing data have been replaced with something else. So there is no missing value here. Titanic problem is a yes and no solution. So I have to use a multi-classification module. So from machine learning, I'm going to use the classification one. I'm use the decision forest, for example, and also the neural network. I just choose them randomly. I'm not going to deep into the algorithm, that's why I choose this one, but they are actually a classification. They can answer the yes and no question both, but so I'm going to run them together to see that which one is more appropriate. So for them, I have to first train the model. So the next step is to actually train them. So here, actually, the data should be here. So you see that is a place that I should connect the model. And here I should set that I'm going to predict the people survive or not survive. Yep. And here also. And also connect them together. And now I have to provide the data. I have to split the data to provide some percentage for training and the rest for that one. So the fraction of the data that we use, we said 70%. Fraction of the rows in the first output, it should be 70%. So I'm just connect them together, and I should provide the data for that one. So for training, I use data for training. So some specific data goes for training. And after that, I'm trained the model, I should actually test that one. So I use the model under the machine learning component for testing. So the rest of the data should goes for actually testing that does the model perform okay or not. So I'm just connect them. Cool. So I create two model, and at the end, I'm going to see that which one is much more appropriate, which model, neural network or decision forest work better. So I'm just around the model, it should be okay. So here you see that this is main structure. If you want to run different models, you should write an R code to run, for example, 3 or 4 other models. Okay. So it's just take a bit to run. The main aim that we actually evaluate the model to see that which algorithm works better. We are going to see that for this data set, multi-class decision forest better or neural network. The evaluate model provide actually some statistics that help us to see that which one better. I'm just look at this one to see that which algorithm work better. And just click here, and you see that for decision forest, that's in the left side, you see that it's about the accuracy is 79%, while for neural network is 82. So for this data set, I think that the neural network work better. Also, you can have another measure. It's a diagram that shows that for people who are not survive in real world, does the algorithm predict well or not? For example, the algorithm, the decision forest predict people not survive in 84%, and they are not survive in real case. So it's good. For neural network, is much higher. It's about 93%. And so you can look at the other also here. Now I create a model. I find that neural network works better. I'm going to create a web service out of it. So to do that, I'm right-click on the train model, and I'm save it as a train model. So I put a name that Titanic Data Science March. Okay, so I'm just save it. Now I'm able to remove the other component. I'm not going to use this one. I'm not going to train this. I'm not going to split the data. Oh, sorry. And I do not need the neural network anymore. I'm not going to evaluate. Also the splitting the data and also the training. So What's left is actually the data here. So I have to go to the train model here, and from the Titanic one, oh yeah, this one. So this is a model that I'm already saved. So I'm just going to use the data just to score it and see what's happened. Before I'm going further, I should remove the survive column from here because I'm not going to train the model anymore, so I do not need the survive column either. To create the web service, I should come here to set up the web service. So if I'm just click here, you see that web service component automatically comes here. So I want that it get an input from here. I'm just run the model to save it, and after that enable actually to publish the model. So here is a component that says that deploy the web service. After the running, I can create a web service out of it. Okay. So I'm just waiting the final steps. Okay, now I can deploy the web service. If I click this, the web service will be shown up to me. That's helped me to actually to use this created model in other applications like R, like C#, like Python. So I just can use this one. If you want to look at it, so I'm just going to open the API of that. So you see that this is the API. It has the input and output. And this is the code, sample code for C#, for Python, and for R. So you can easily copy and paste them and put in the appropriate data. For example, here is the input. So you see that we need passenger class, gender, age for that, and also the rest. What we can do also, we can test here. So for example, I said the passenger is this, the male, with the age of 56. And if I run it, the result should be shown here. So you see that it's happened here. So with 83%, these people are not going to survive. There is also option that you can also go through the Excel. I will show that one after I'm back from the R session. So it's all about, there's a very, very brief demo about the Azure ML. That's what's the Azure ML and how it works. Now I'm going to talk a bit about the actually R. What is the R? R is the statistical programming. So I'm just run the session. So R is a statistical programming language. It's free, open source. It's really powerful. It's very famous, and most of the data scientists, many of my data scientists use R. Growing demand. R is the highest paid IT skills in 2000, according to the dice.com 2014. R is used by 70 of data miners, and R is a 15 actually all programming language. And yeah, so this is R really cool and really famous. So the good thing is that the Azure Machine Learning actually is connected with the R. I'm going to show you a very brief demo on R. So this is R Studio. This is R Studio that many data scientists use them. So here is the place that I can write my code. It's the place that shows the result. It's the place that shows the diagram. And here is the history panel. I'm going to show you a very simple R code about getting the data from outside and drawing the diagram. So first, just close this one. I'm going to import the data. So here is a place that I can import the data. So I'm just import it. I just click and run it. I made a mistake. I think so here. Yep. Should have put a slash here. Yep. So just run again. Yep. And by command view, I can see the data structure. So it's about the California diary data. That's about the month, year, the consumption, the production of the cottage cheese, ice cream, and milk production, and also the fat price. So it's a very simple data here. If you want to look at a data actually summary about that, how many rows and what sort of column we have. So we have about 228 observation of rows and also 9 columns or 9 variables. It's similar to the columns that we have in table. And you see that the columns that we have, the type and the sample of their value. Look at the months here. Months is actually January, February, March. Is a character. We are going to change it to the discrete variable, is a factor. So I'm going to use to change the data type from the character to the factor. So I'm just run it. And if I again look at the summary, you see that you see that it changed to the factor, but it says that there are 14 distinctive factors. It's not actually like that because you have April and April, APR and April. So it should be consistent. So I'm going to use the substring code to remove the rest of the code. So now the data should be available. So it should be okay now. If I look at the summary, you see that now I have 12 variables. So now you can also look at the diagram here. So here is actually comparison between the cottage production, ice cream, milk, and the fat price. So you can have a actually look at the 4 different parameters here. Okay. I'm going to show this code in the Azure ML environment to see that how is possible. So back to the experiment, I'm going to create a new one. I already put the diary data here, and to write my code, I'm using the component execute R code. So here I'm just connect them. So there is a 2 place that you can connect the data set and also 1 place to connect the zip file. By clicking here, I'm able to write all of my code here. So you see that there's a component MA input port that identify the which port, which node you are going to use. So I'm going to actually copy and paste the data, the code that I have. So I said that get the data from port 1, so I'm connected to this. I want that change the data type. So if you look at the data here for mostly the month, you see that it has 14 unique value. Is the data type is actually string. So I'm going to change it. And also I want to show the diagram here, and as an output I want to show the data. So here is a place that shows the data, and here is a place that shows the actually the diagram to me. Okay, so I'm just run the code and waiting till run. So it's really easy. You see that how it's really easy. You just copy and paste your R code and you can create it and create the web service here. So yeah, it should be done now. After that, I will show you that how you publish a web service through the R. So just look at the result of the data set here. So if I click on this, you see now it's a categorical feature and it has 12 value. And also I can see the same graph that I saw in our studio here. So yeah, so it's really easy. You see that how much easy to work with that. Okay, so I'm going to show another cool things that you can do with R. I'm going to write a code actually to create a function in RStudio and then publish a web service through that. So I'm just copy and paste here. Okay. So what I have is actually, my aim is to run a code to create a function in R and then create a web service out of that. To do that, I first to install some main component. So the Azure ML should be installed in R first, and maybe it take a bit time to run. And then also I need the library of that. And also I have to install the JSON and the other component that useful for creating the web services. Maybe take a bit time. So I have to, as you see that I should install, sorry. Okay, so this here shows that there is a process. So it's going to install some packages like RQL for RCrawler, and also the JSON and the other HTTR data table and the rest into the R. So it helped me actually to run my function. The function that I have is actually a very simple function. So it's actually the add function that get the X and Y as the input, and as the output return the result. There is a function in R that's name is publish web service. It get the name of the function. So you see here, it get the name of the the name of the web service that we want. So we can change it, get the list of the input, get the list of the output, and also it gets the workspace ID and authentication token. So for these two parameters, if I want to show you, you should come to the setting, and here you see that there's the authentication token, the workspace ID here, so you can copy from here. And for authentication token, you can copy from here. So back to the model. Okay, so I have to just I think that there was maybe a problem here on the R. So I'm just, oh, there's an error on that one. So I'm just going to run again and install the code here. Again, there's a problem on the R. And yeah, so it's installing perfectly. I can change the name to the, for example, to see that in Azure ML, I will change the name so you can see that. So yep, everything seems that run perfectly. Okay. Okay, now I have everything. I'm provide the attribute that I want, and now I can run the code. I just change it to the data science group. So I'm run the code here. So if I'm back to the web service here, I should see the actually created web service there. So I just back here, check my web service. I should see here, just at the time. Should be open now. So back to the web service. Oh yeah, add data science. So here is a web service that I'm created through the R. So there's a possibility, so it has the same web service that we have, and also there's a possibility that you run it through the Excel. So I'm just click here to download the Excel file, and I'm going to show the that on the Excel format. So the add-on on the Excel will be available. So it's really awesome. So you can do everything that you can do with Excel. You get a prediction from Azure ML and then provide the presentation using the Microsoft Power Queries, Power Pivot, and to get a better insight. So you can use that one. There are many add-ons, but this one is actually the one that is primary use and is really useful. So any questions so far? Okay. So I'm just waiting till the Excel comes up. There's a cool thing about the before that comes, I will show. There's a cool thing about the R. There's an R server that's recently R Studio, sorry, that has been recently released. It's really good environment. I will provide some presentation later, so it's really just check the post about that one. And also there is a as I said before, there is a comparison between there's a previous one that was related to SQL Server. There's a data mining that there was exist in 2005. There's a comparison between them. So if someone is familiar with that one, you can see the comparison. Unfortunately, here we just have some canned algorithm. We cannot able to change them. But here you see that how you can change and write your own R code. There's a DMX code in SQL Server one that is really you can write the code in .NET like whatever you do in actually SQL Server. You also can write the code there. There are more visual in previous version. This one is less, and you can use the other options like Power Pivot, Power View, and the Power Map to get a better visualization. And there are many online community for Azure ML. So I'm just back to see that my Excel is available or not. Yep, this is the Excel one. So here is the add-on for Azure Machine Learning. So you see that it's provide. I'm using this is the web service that I'm already created. I'm click on that. Here I'm going to use to set that use the sample data. So for example, 65 to 98. I use some random data for that one. And I'm going to set that use this data as an input. And I'm going to show the data in column I1. So auto predict and should be work. So I'm just do again. Oh, sometimes maybe it's not. There's more error here. It should work. I should change it to the E1 maybe. Okay, so it's not working now. Just change. So it's not working with some reason that I know, but however it's accessible and you can actually see the data here. Maybe I made a mistake. So as I said that also for the free version of the Azure Machine Learning, you have different options. So you can do a lot of things, but if you want more functionality, you provide a standard division that you should pay. For example, about the staging, there are some common things like staging the web API, production API. There are some common things. So if I'm just click and back to the website, so you see the difference of the pricing of them. So here, so this is a place for that you can see that how it happens. So for example, there's a limitation on maximum of the module per experimentation. So 100 is not actually small one. But if you need more, you should provide using access to the paid version. Maximum experimentation duration, that is for the session, so it's 1 hour free. You have 10 gigabyte access, so it's really cool, and also you can look at that one. So machine learning studio usage, $1 per studio per hour, and so yeah, just go there. And for more information, you can use the machine learning website. This data science virtual chapter is really great to provide this, and also Microsoft Ignite conference provide really good information. So yeah, thank you for any questions. I couldn't see any question here. Yeah, I'm actually done with the presentation, Luis. So yeah.
Yeah, thank you so much for this presentation. I just wanted to remind everybody to keep an eye on our website, datascience.sqlpass.org. We have already posted the next presentation for the month of April, and we have a few other presentations queued up that could make it in the schedule before the one that we have published already. So just keep an eye. We'll also update you via email. And if no one has any questions, then I'd like to thank everybody for joining us today. Thank you, Leila, so much again for this great presentation. And we look forward to catching up with everybody in the next meeting.
Yeah, thank you, Luis. Thank you. Have a good day.
You too.
Bye.
Thanks.
Thank you. Bye.